Hi everyone, I hope you're having a good weekend. I'm going to go over your Unit 1 assessment review. Remember that you can pause or go back and rewind this video and watch it as many times as you need if I'm going too fast. So the first section is on vocabulary. It says use figure 1 to explore the vocabulary from this unit. In number 1, it says scale copy. These are scale copies. What is something we know about the figures? What do we know about the lengths of the sides? What do we know about the angles? So we need to make sure we talk about both the sides and the angles. Well, if we know that these are scale copies, then there's some things that we automatically know. We know that both of these figures are the same shape, but they, of course, are different sizes. So we know that since the figures are scaled copies, they are the same shape and just as a reminder, whenever we say that they're the same shape, that means that they're not being stretched or distorted. So they are the same shape, just different sizes. Okay, and then if we're saying that they're the same shape and different sizes, there's some rules that we need to follow, talking about both sides and angles. First, we'll talk about staying the same shape. If the two figures are the same shape, that means that the angle measures do not change. So I'm going to write down that we know the angle measures are the same in both figures. And what I mean by that is if this right here is a 90-degree angle, then on this figure, this corresponding angle over here will also be 90 degrees. Just because it's getting larger does not make the angle measurement any larger. The other thing that we need to talk about are the sides. Since these are scaled copies, we know that the sides are going to increase multiplicatively, which means that they're increasing by the same scale factor. So we know the lengths of all sides are increased, and we know that they're increased because they're getting bigger. This is creating an enlargement, are increased by the same scale factor. Okay, and now we've answered all three questions. Question number 2 asks us about scale factor. It asks, what is the scale factor going from the original to the enlargement? And then it asks, what is the scale factor going from the enlargement to the original? So let's worry about the first question right now. So this one's going from the original to the enlargement. So that means that we're going from this figure over here over to this figure over here. We only have two given lengths on corresponding sides. We have over here that this side is 2, and then its corresponding side on the scaled copy is 6. So we have to figure out how we can get from 2 to 6 multiplicatively. Well, I know that 2 times 3 gives me 6. So that means that my scale factor is 3. It's getting larger by 3. So what's the scale factor? The scale factor is 3. Then it asks us, how about if we go from the enlargement to the original? Well, we can use the same sides, and if I know that I wanted to get from 6 back to 2, I know that that would be dividing by 3. But whenever we talk about scale factor, we need to talk about what the relationship is multiplicatively. So remember that we talked about changing a division problem. Dividing by 3 is the same thing. You can change 3 to a fraction, change it to 3/1. And to change that to multiplication, you simply need to find its reciprocal. In other words, flip the fraction over. So dividing by 3 is the same thing as multiplying by 1/3. That means that our scale copy going from the enlargement to the original is 1/3. The smaller figure is 1/3 the size of the larger figure. All right, the next section's all on corresponding parts. So it asks, what's the corresponding length to AB on EFGH? So this is the second figure of the enlargement. So AB, you can see, goes along the top, goes from A to B. And so on the corresponding length has to be in the same space on our other figure. So that's going to be length EF. So we're going to call that segment EF. Matches with segment AB. Question B, what's the corresponding angle to EHG on figure ABCD? Well, angle EHG is talking about this angle over here. And so the corresponding angle on our original figure is angle ADC. Angle ADC. Question C, segment HG is 3 times as long as segment what? Well, if we go back up to the top, we have segment HG over here. Well, we know that the scale factor going from our original to our enlargement is 3. So it should be 3 times bigger than its corresponding side, which would be DC. And we can double check that with our math. We know that if we're going by a scale factor of 3, all of our numbers are being multiplied by 3. So this length would be 21, which is in fact 3 times bigger than 7. So then we know that HG is 3 times as long as segment DC. Question D, segment DA is 1/3 as long as segment what? Well, again, we're talking about DA, and we know that this is 1/3 of segment EH because that's where we originally found that scale factor going from our enlargement to our original, multiplying by 1/3. 1/3 of 6 is 2. So that's going to be that segment DA is 1/3 the length of segment HE. And I know I said it a little bit incorrectly earlier. Because it specifically says D to A, you need to make sure that you're starting from H to E because those are our corresponding points. D corresponds with H. All right, the final problem on this side is about drawing a scale copy. It says draw a scale copy using the scale factor of 2. So that means that every side should get 2 times bigger, multiplying by 2 or doubling. Well, I can see from straight lines that this side is about 2 units long. This side is also 2 units long. Remember that you can't count the lengths of diagonals, but you can create sides along it to figure it out. So this side is also 2 and 2, and these sides over here are 2 and 2. Okay, so I know that I'm multiplying all of these by a scale factor of 2, so all of my 2's are going to become 4's. So I can lightly sketch out that this 2 up here in the corner now has become a 4. And I'm sorry, I apologize that the graph, one of the units got cut down at the bottom. So this unit, this side over here, goes from 2 to 4 as well. So it is going to extend beyond the graph that showed up on your paper to make this 4 long. Okay, then I know that this side is going to start 4 units away, so I can lightly sketch in that. And you could erase this part later since I'm in pen, I can't. And then this side is also becoming 4 units long. Okay, then all I need to know is that this corner over here connects to this corner over here, And I should be using a ruler, but I don't have one with me at the moment. And you will nicely connect those lines. And then you can connect these lines as well. And now we've created a figure that is double the shape.